8.3, solving linear systems by substitution. We're going to be substituting in today. No graphing involved. Using our knowledge and recalling how to solve equations. The steps you need to follow. Number one, first you have to identify which equation is solved for any variable. So you're going to want to look for like x equals 2y minus 3. All right? Something where x is all by itself, or it might be the y equals 4x. All right? Y was solved all by itself. That's what that means. Identify each equation, which equation is solved for any variable. Then you're going to substitute in this equation in the other one. So you'll take that or that and you'll substitute it. Then you solve it using your skills of solving equations. You use the solution to solve the other variable using either equation. I'll show you that in a sec. And then write the solution as an ordered pair. And then you'll check it. I'll show you how to check it to see if you did it right. Two vocab. Again, the special ones, if they don't have one solution, like your x and your y, you're going to end up having a no solution. And that's if your lines are what? Parallel. So if you have parallel lines, it's going to be no solution. And what's going to happen is your variables are going to cancel each other out. And then, for an example, after your variables cancel out, if the numbers on each side of the equal sign are different, you know that they're parallel. So it would be no solution. Because we don't have a graph to look at now to know they're parallel. The variables cancel out and you have different numbers on each side of the equal sign, they will be parallel. If the variables cancel out and the numbers on each side of the equal sign are identical, then you know that it is infinitely many solutions. They will be the same line. One line, infinitely many solutions. So anytime your variables cancel each other out and just leave you with numbers, you know that's the special case where it'll either be no solution, numbers are different, or infinitely many, where the numbers are the same on each side. Let's practice. So in this situation, it says, solve each linear system of equations using the substitution method. So always read, like when we take our quiz or test, read, because you have to solve it using what? Maybe I'll say solve it by graphing. Solve it by substitution. This one, today we're learning substitution method. Now if you notice this first equation and the second equation, which one of these equations is solved for a variable by itself? Top or bottom? Yeah, the first one. This top one is solved for y, all by itself. 1y equals. So I know y equals x plus 2, right? Okay, so if y equals x plus 2, I want to substitute this x plus 2 in for the y. So you want to cross the y out or take that y out of this second equation, right? Because it's the y. You take it out. We're going to substitute this in its place. And I suggest you keep them in order because of the signs and adding things in between. Another thing that's kind of helpful is parentheses. Now in this case it's not crucial because there's a positive sign in front of it. So basically that would be, remember that assumed 1. Would anything change if we did the distributive property here? This would still be a 2x, but what's a positive 1 times x? Still is just a positive what? 1x. Positive 1 times a positive 2 is still a positive 2. Equals 8. Alright? Now what do we do to solve the equation? To finish up. What's the next step?
Combine by 2.
Combine what? Combine what? Like terms, and I get 3x.
Plus 2.
Good. Don't forget to bring down the plus 2 equals 8. Now what? Subtract 2, Red Rover. Subtract 2. Those cancel out. Subtract 2. So now I still have 3x equals, what's 8 minus 2?
6.
And my final step, multiply or divide.
1,
Both sides by
3,
3. What does x equal? 2. We're half done. The longest part, I think, the hardest part is done. So we take that x, and remember we said our answer is always in an ordered pair, unless it's a no solution or an infinitely many. Okay, so does this x, does that 2 go here or here?
second one,
First or second?
first,
Remember, our ordered pairs are always x, y, alphabetical order, so it goes in the first one. We're half done with our problem. So now all we have to do is go back to our original. Remember, our original was y equals x plus 2, and this was 2x plus y. I'll rewrite that. This one was 2x plus y equaled 8. These were my original two equations. I can take that 2 and put it in for the x either here or here. It doesn't matter which one because I'll get the same answer for either one. Majority would pick, and I would pick, the easy one, wouldn't you? Put 2 in here for this x. What is y equals 2 plus 2 then? Y would equal 4. Let's see if it works here. If I put 2 in here, is 2 times 2 is, oh, whoops, my bad. Yeah, I'll rewrite it over here. 2, and I'm going to put 2 in here. So 2 times 2 plus y equals 8. What is this? 4 plus y equals 8. And then what? We would subtract 4. Y equals what? 4. Did it work out again there? It did. And checking it, you do the same thing. You just put both of these in over here in your originals. So if we put our 2's in here for the x's, and we put 4 in for the y's, do those equations equal each other? Does 4 equal 2 plus 2? Sure does. What's 2 times 2? Plus 4? Does 8 equal 8? So we know we did it right, because it works in both equations. Right, letter B. Now this one's not solved. The easy one that's all by itself isn't y this time, it's x. X equals, they're telling us y minus 1. So x equals y minus 1. I'm going to go down here, I'm going to cross out the x. Okay, I'm going to take that x out. So it's x, and I'm going to put this in for the x. Now they're saying x is this. And we're keeping them in order. We don't want to mess them around. We don't want to mess with signs. Are parentheses crucial here or not? Do I need parentheses? Would it make a difference on that one? No. Because that would just still stay y minus 1 plus 3y equals 11, right? Put your assumed ones in there. Combine like terms. How many y's would I have?
4 y's.
I would have 4y, then what? Yep. Negative 1 or minus 1 equals 11. Now I need to do what? Yep. Inverse operation, red rover, send over, make that a 0, plus 1 over here. So now I have 4y equals, I brought that down, 11 plus 1 is 12. Multiply or divide now. Divide both sides by the 4. 4 divided by 4 is 1, so I have 1y, or y equals 12 divided by 4 is? 3. So in my ordered pair for my answer, which you need to have, where does the 3 go? First or the second slot?
Second.
Yep, x, y, or x, or y. So we solved for y this time, so it goes here. Now let's go up to here to our original equations, which were x equals y minus 1 and x plus 3y equals 11. Which one do you want to use? Yeah, me too. The top one, the easy one. So put 3 in where? Here or here?
Y.
For the y, because we solved for y equals 3. It's in the y spot. 3 minus 1 is x equals 2. Our ordered pair is 2 and 3. So if I put a 2 in here, does 2 equal 3 minus 1? Yep. What if I put a 2 in here and a 3 here? What is 3 times 3? Is 2 plus 9, 11? Yay, we're brilliant. So our answer is correct. I'm going to give you a couple minutes to try to solve this one and hold up on your boards what you come up with. Example C. So did we end up with an ordered pair for this one?
No.
No, you did not. You want to take, this one is for y, so we want to take the y out, put this in for our y. Keep them in order. Now here, parentheses, does anything change on this one? That would be like a positive 1. Positive 1 times a negative 2x, does that change? Positive times a negative is a negative, so that turns into a negative 2x, or stays at negative 2x. Positive times a positive is a positive 7. Bring down your 2x equals 7. Now what happens here? What is 2x minus 2x when we combine like terms? 2x, what's 2 minus 2? 0. Do we write 0x? No. These cancel each other out and make 0. We still have our 7 left here, right? 7 equals 7. And when we did our vocab, what happens when the variables cancel out and the numbers are identical on both sides? Is it no solution or infinitely many solutions? It's infinitely many solutions. So if you graphed both of these originals on a graph, you'd end up with one line. They are the same line, so your answer needs to be written as infinitely many. Infinitely many solutions for that one. All right, now we have D. I'll give you a couple seconds to figure out for D. Hold up your answer on your boards when you get the answer for D, please. Always rewrite your equation nice and neat to keep things in order. So here it's solved for x. So we have to take this x out right here and put this in its place. So we're going to put a negative y plus 5 in the place for that x. And then we still have this part of the equation left, so it's plus y equals 7. Solve for that. What's a negative 1y plus 1y? What happened again? Yep, it's a special case again. They canceled each other out. Left me with 5 equals 7. Is it parallel or the same line? Parallel. Yep, these two lines, if we graph them, would be parallel. So if they're parallel, the answer would be no solution. No solution. These are different numbers and the variable canceled out. All right, the last one, letter E. I'll help you get set up. What are we going to cross out down here, the 2x or the y?
Y.
Right, because it says y is this, so we're going to cancel that out. Keep our 2x, and then we're going to go plus a negative 3x equals 0. What does a positive times a negative turn into? A negative. So that turns into 2x minus 3x equals 0. I'll tell you this, they don't cancel out. It's not a special case. You will have an ordered pair for an answer. When you get the answer, raise your hand. I'll come check it. If you have the right answer, you can start your homework, which is page 7 and 8 in the packet. So if you finish it up, it's 2 minus 3x is a negative 1x equals 0. And we divide both sides by negative 1. X equals not a negative 1. 0 divided by anything is 0. So our x is 0. Go up here, put my x as my 0. I'm going to use that first equation. That's the easiest. Another mistake that was made, put a 0 in for here. Negative 3 times 0 is not a negative 3. It is 0. So your ordered pair, those two lines are going to cross at the what? At the origin. Those two lines are going to intersect at the origin. 0, 0 is the solution to that system. All right, pages 7 and 8.